Generating queries corresponding to natural language questions is a long standing problem. Traditional approaches don't support flexible natural language, while newer neural network based methods require a large amount of data and they cannot produce highly complex queries. Here we propose a method that produces complex queries from natural language questions on a specific schema with high accuracy, while requiring only a small dataset of question query pairs. Our approach is to transform the query generation problem into an intent classification and slot filling problem. We first analyze queries in the examples given to build a tree of intents. The tree is constructed by progressively splitting the set of example queries based on data source, aggregations, data to return, and filters to use. We use a BERT fine-tuned intent classification and slot filling IDSF model that is jointly trained for both tasks. For intent classification, the model is trained to predict the intent corresponding to a user question. We use all intents at a specific level in the intent tree as classes. Each natural language question then corresponds to exactly one intent class. The model is also jointly trained to predict which tokens from the input question represent slot values and which slots should be filled with those values. The slot values predicted by the IDSF model may need to be transformed before they can be used in the queries. The transformation is done using various heuristic methods. Depending on the level of the intent predicted, various algorithms and models are used for query generation. We use this approach to build a conversational analytics system. We compare the performance of this approach with a state-of-the-art text to SQL approach by Ben Boggin and others. Their GNN model in a schema zero-shot mode had very low accuracy on our dataset. It improved after fine-tuning on our dataset, but our approach performed substantially better with 92% accuracy. This approach can also be used to generate commands in an arbitrary non-SQL syntax by pre-processing the commands into an isomorphic SQL command and then converting back after inference. To conclude, our approach produces highly complex queries from natural language questions on a specific schema with high accuracy, while requiring only a small dataset of question query pairs. Thank you, and we look forward to your questions.